All right, so two-step equations means there's going to literally be two steps. Here's the hint. The last step is always the exponent, right? Because if we think about this is going way back in time, PEMDAS. So PEMDAS, well, that was how we simplified, right? But to solve, you went the other way. SAD-MEP, right? SAD-MEP. And what does that stand for? Well, this is kind of going way back with that. This was subtract. Let me just do it like this. Subtract, add, divide, multiply, exponents, and then parentheses. So when you're going to solve an equation, you need to follow SAD-MEP. So it's PEMDAS in reverse. So you do these things first. So, and these things are paired. So you either add or subtract. You always go left to right. So whichever one comes first, going left or right. If you have addition or subtraction, you get rid of that first. Then if you have multiplication or division, you get rid of that next. Again, left to right. Then you do your exponents. And that's what we're focused on here. So these exponents, well, if you have any addition or if you have any multiplication or subtraction or division, those are going to come first. Get rid of those things before your exponents. Parentheses, you know, we'll get to stuff like that eventually. We probably won't this year, but we would have. But we're not going to run into parentheses right now. So exponents is going to be the last thing. So what that means is that until you have x squared left on the one side of the equation, that is the only time when you square root. You cannot square root when you have 2x squared. Will not work. Cannot do that. So pay attention to that. So there's a setup. Let's see if we can apply this to a few problems. So let's look at number 8. We have x squared plus 1 equals 50. So what I'm thinking here is, okay, I know I need to solve this equation. And as I just said, okay, we need to get rid of everything except for the squared first. So we have a plus 1 on the side of the equation. So what do I want to do? I want a minus 1 to both sides. And what do we get? We get x. So these canceled out. So we get x squared equals, sorry, I like to keep my colors consistent. X squared equals 50 minus 1 is 49. We can drop down our equal sign. Okay, we're not quite done yet because we have this squared. So what are we going to do now? Well, all I have left is x squared over here. So now I can square root. And remember, you got to do it to both sides still. So that square root's going to cancel out. And what do we have left? Well, it's x equals, what's the square root of 49? If you don't know, you go to your trusty calculator. And that's actually the same problem we just did a little bit ago. Square root of 49. I'm going to see how to type that in. It's right here. Square root of 49 and it equals 7. So x equals 7. Boom. Okay, I actually want to skip over the number 10 really quick as well. So you're going to do number 9. I'm going to skip to number 10 as a second example, though, just so that just so we see this one too. So now we have 2x squared equals 18. Well, again, we need x squared by itself before we can square root. So we got to get rid of this 2. It's multiplying, so what do I need to do? Well, I am going to divide that 2. So I need to do that first. Okay, 2 divided by 2 is 1, so that effectively cancels it out because 1x squared is just x squared. 18 divided by 2 is 9. We'll pull down our equals and we'll pull down our x squared. Okay, now I'm going to think about this one more time. I have x squared, so just same thing. Now that all I have left is x squared, I can square root both sides. So cancel that square out. And what we're going to be left with is x equals the square root of 9, which most of us probably know is 3. And if you didn't know, you go to your trusty calculator. Square root of 9 is 3. Perfect. So x equals 3. Okay, so you're going to do numbers 9 and numbers 11.